given the function f of x is equal to x plus 1 over x squared plus x minus 6. And the question here, two questions are asking us here. One is to find all the values for which this function part A is undefined. So undefined means when we have something over 0. So under what condition this would be undefined? When what we have at the bottom of the fraction is equal to 0. So what we do is we let x squared plus x minus 6 equal to 0. If x squared plus x minus 6 is equal to 0, this whole thing would be undefined. So we need to solve for this. If it's not factorable, you use quadratic formula, but this looks like it's factorable. So let's go ahead and factor that. So we're going to put x and x here, 2 and 3, looking for two numbers. When you multiply them together, you get 6. And then when you add them up, you get plus 1. So I'm going to make the 3 plus and 2 minus, and the product minus 2 and plus 3 would be minus 6. So if we factor this, and you let each of these be equal to 0, you would say x minus 2 is equal to 0, therefore x is equal to 2. If x is equal to 2, this whole thing would be undefined, or x plus 3 equal to 0, that would result into x equal to negative 3. So if x is equal to 2, if x is equal to negative 3, this whole thing would become undefined. So you don't want to assign those two values for x. That would be part A. For part B, they're saying that for what value of x, this whole thing would be equal to 0. Well, in order to this equal to 0, only the top portion would be equal to 0. So if x plus 1 equal to 0, that means if x is equal to minus 1, if x is equal to minus 1, this whole thing would be equal to 0. So what you need to pay attention is when it says under what condition your expression is undefined, you only pay attention to what you have at the bottom of the fraction. You let that equal to 0 and solve for x. When it says if it's equal to 0, you pay attention to the top of the fraction. You say, okay, for what value of x this expression would be undefined, then I would assign 0 to the top of the fraction. Here we're going to simplify this, and the first thing you look for is to factor this. If it's factorable, you factor it. It looks like what I have at the bottom of the fraction is factorable. I get a difference of a square. If you recall, if I have x squared minus y squared, that would factor to x minus y times x plus y. So if I go ahead and factor this, my x is x, my y is 10. 10 squared would be 100. So I would factor that to x minus 10 times x plus 10. What I have at the top of the fraction is 10 minus x. It's not exactly the same. This is 10 minus x, this is x minus 10. There are two ways we can deal with this. One is to just simply factor minus 1 out of either of these two terms. These two terms are the one that you want to factor minus 1. Or you can multiply the top and bottom fraction by negative 1. That seems to be more straightforward for most of the students I've been showing these two methods. So I'm going to go ahead and look at this as multiplying the top and bottom of the fraction by minus 1. When you multiply the top of the fraction by minus 1 and bottom of the fraction by minus 1, you're really not changing what you had originally. Minus 1 or minus 1 would be equal to 1. However, if I go ahead and distribute this minus 1 only to one of these, what's going to happen is we would get minus 10 plus x at the top of the fraction. I'm not going to distribute the minus at the bottom of the fraction because I already have x minus 10 here. And I really have x minus 10 at the top of the fraction now. So if I just go ahead and switch this around, the top of the fraction would be x minus 10, which matches what I have at the bottom of the fraction, x minus 10. This can be reduced now, but don't forget we have this minus 1 still sitting here, times x plus 10. So that's one way to make these equal, so I can reduce x minus 10. In the top of the fraction, I get 1. Bottom of the fraction, I get minus x plus 10. Now that minus really can go to the top, bottom of the fraction, or right front of the fraction. So I can write this as minus 1 over x plus 10 if you want. Or I can write minus right front of that over 1 over x plus 10. However you do this would be fine. So note that I made 10 minus x and x minus 10 look like each other by simply multiplying one of them by minus 1. That's one way to look at it. Another way to look at this is if I factor a minus 1 out of one of these, if I factor a minus 1 out of one of these, then one would become equivalent to the other one. So this is how you simplify that. Here we want to simplify. So what I need to do is to factor where it's possible. In this case, we have x plus 3 at the top of the fraction. I can go ahead and factor this to x and x. So 2 and 3, 4, 6. You want to add up to be plus 1. So I'm going to put plus 3 and minus 2 here. Minus 2 times plus 3 is minus 6. Everything's there. So now I can go ahead and reduce. Simple as that. You reduce them, would be 1 over x minus 2. Here you want to add, so I need to find the LCD. And before I do that, I need to factor. Looks like this is factorable. So this would become x. And for 2, I'm going to use 1 and 2. And then if both are positive, I'm going to add up to 3. So my LCD then is x plus 2 times x plus 1. So the goal here is to make all these 3 denominator equal to the LCD. It looks like we're missing some terms here. For the first one, I have x plus 2 already. I'm missing x plus 1. So I need to multiply the first fraction by x plus 1 over x plus 1. And the second one, I have x plus 1 at the bottom fraction, so I'm missing x plus 2. You need to multiply that to top and bottom of the fraction. However, I don't need anything for the third one. So the first one, x over x plus 2, need to be multiplied by x plus 1 over x plus 1. Then the second term, 3 over x plus 1, need to be multiplied by x plus 2 over x plus 2. And the last one is already there, x plus 1 times x plus 2. And then I don't have to really multiply this by anything. I get 3x plus 4 at the top of the fraction and over LCD. So now I can go ahead and combine these because we have same LCD. So we go ahead and write that down as x plus 1 times x plus 2 at the bottom of the fraction. Now I can go ahead and multiply this. I can distribute this x here. Here I get x squared plus x. Here I'm going to distribute this 3 here. I would get 3x plus 6. So let's record all that here. X squared plus x plus 3x plus 6. Now this minus should be distributed with the next one would be minus 3x minus 4. So now I can go ahead and combine like terms. I get x squared here. If I add all the x together, I get 1x and 3x minus 3x. Looks like plus 3x minus 3x add up to 0. So you end up getting plus x here only. And for the constant, you get 6 minus 4. That will give you plus 2. The last step is to see if I can factor this and reduce any part of this by what I have at the bottom of the fraction. The question is this factorable? Well, it looks like 1 and 2 would give me the product of 2. However, I won't be able to make plus 1 out of that. So I cannot find two numbers. When I multiply them together, I get 2. And when I add them up, I get plus 1. If I pick 1 and 2, if I want to make a middle term, I have to have plus 2 and minus 1. That would give me plus 1x. However, the product of these two is not going to give me plus 2. So this is prime. It's not factorable. So this would be my final answer here. Here you want to add, and the LCD is something that you want to look for first. If you look at my denominators, I have x minus 5 and 5 minus x. If you recall, I can make this look alike by simply multiplying one of them by -1 or factor a -1 out of that. So what I'm going to do is I'm going to multiply the second fraction here by -1 over -1. -1 over -1 is really is 1. So I'm not affecting the second fraction here. So I'm going to multiply the second fraction by -1 over -1. What's going to happen here is if I distribute this minus, this would become minus 5 plus x, which is really is x minus 5, which I have here. Now the LCD would be x minus 5. So now I have x minus 5 as my LCD. So now I can allow to add what I have at the top of the fraction. Here I have 1 plus, what do I have here? Minus 1. 1 plus minus 1 is equal to 0. So you get 0 over x minus 5, which is equal to 0. Here we're going to solve, and we have a variable at the bottom of the fraction. We need to eliminate that. The first thing we want to do is to find the LCD among everything. LCD among all those three terms. To find that, I need to factor all these completely. This is difference of square. So I get x minus 1 times x plus 1. So now I can see my LCD among all these three terms would be x minus 1 times x plus 1. Now you want to make a note here, because I have a variable at the bottom of the fraction. Right away you want to make a note that x minus 1 cannot be equal to 0. Therefore x cannot be equal to 1. At the same time, x plus 1 cannot be equal to 0. That means x cannot be equal to -1. We're making these two notes here. So if I solve this equation and I find x equal to 1 or minus 1, I'm going to exclude those as part of my final solution. So the next step is to multiply each term by LCD here. This would be x minus 1 times x plus 1 over 1. There are three terms here, which I need to multiply each term by that. So if I do the same thing with the next one and the last one, that would guarantees to eliminate all the fractions that I have here. The first term here is 2x over x minus 1 times x plus 1. You can see how that x minus 1 times x plus 1 would drop to 1. Then I have equal sign here. Next term would be 2 over x plus 1. You saw x plus 1 cancels also. And the last term would be 1 over x minus 1. So by doing this, you can see I'm reducing all these fractions, all turns to 1. So I would have a linear equation. The first one would turn into only 2x. Next one would be 2 times x minus 1 minus, this would be 1 times x plus 1. So this is a linear equation that everyone should know how to solve by now. You can distribute. So I get 2x is equal to 2x minus 2. I'm going to distribute this minus. I get minus x minus 1. And then I can move all the x to one side of the equation by subtracting 2x from both sides of the equation and add x to both sides of the equation. You get minus 2 minus 1. That adds up to minus 3. This to add up to 0. So it looks like x is equal to minus 3. So this would be my solution. You want to check, make sure this is not one of those restricted one. It's not. We said x cannot be equal to 1. X cannot be equal to -1. And that's not either of them. So x is equal to -3 is the solution. Here we're going to solve, and we have fraction. We have our variable at the bottom of the fraction. The first thing we want to do is find the LCD. And before I do that, I need to factor this. This is difference of the square would be x minus 2 times x plus 2. So it looks like my LCD would be x minus 2 times x plus 2 over 1. If I multiply each term by LCD, which is x minus 2 times x plus 2, that would guarantees to eliminate all the fractions. So we have three terms to multiply each term of those with LCD. The next step would be to simply eliminate the fractions. The first term here is x over x minus 2. So x minus 2 cancels right there. And the next term would be 1 over x plus 2. So x plus 2 cancels. And then equal to 8 over x minus 2 times x plus 2. All right, so remember why we did that. We did that to eliminate the fraction. So the next step is to reduce. All this will reduce us to 1. So now I get the linear equation out of that. The first one would give me x times x plus 2 plus, this would be 1 times x minus 2 is equal to, this would be just 8. When you distribute this, you get x squared plus 2x plus x minus 2. I'm going to move everything to one side of the equation by subtracting 8 from both sides of the equation also, so I can combine like terms. I get x squared, I get 2x plus 1x, I give me plus 3x, minus 2 minus 8 will give me minus 10. And this is what you need to factor. It's a second order equation. It's factorable. I'm going to open 2 parentheses. This becomes x and x. For negative 10, I'm going to look for 5 and 2. You want to add up to plus 3. So 5 has to be put to plus, 2 has to be put to minus, plus 5 times minus 2 still is negative 10. So I'm going to let each of these be equal to 0 and simply solve for x. So x equal to minus 5, or x minus 2 is equal to 0, x equal to 2. Now these are my solutions. I have to check my restrictions. We do have a couple of restrictions here. X minus 2 cannot be equal to 0, means x cannot be equal to 2. X plus 2 cannot be equal to 0. X cannot be equal to negative 2. And looks like that we find one of those restrictions here. X, we said, cannot be equal to 2. So this is not a real solution. The only solution we have here would be minus 5. Okay, here we want to find the domain, all intercept, all asymptotes for f of x is equal to this function here that we have. And we also want to graph them. All right, the first thing we want to do is to look for the domain. So the domain would be the values of x that would make this undefined. So we're going to look at what we have at the bottom of the fraction. So we want to make sure that x squared minus 6x plus 8 is not equal to 0. Because if that's equal to 0, then this whole thing becomes undefined. So we need to factor this and see for what value of x this would be equal to 0. So this would be x, and 2 and 4. We want to add up to be minus 6. So both has to be minus here. Minus 2 minus 4 give you minus 6. Minus 2 times minus 4 give you plus 8. So it looks like when x plus 2 is equal to 0, that results into x is equal to 2. So if I let this equal to 0, these are the solutions I would get for this. X minus 4 is equal to 0. X is equal to 4. So these are really the restrictions. You cannot let x equal to 2. You cannot let x equal to 4. So what that means is my domain would be all the numbers from negative infinity to 2, not including 2. So I'm going to use the parentheses here. And then continues from 2 all the way to 4, not including 4. And then from 4 to positive infinity. That would be my domain. Just by finding those values, we can find the domain. To find the x and y intercepts, we can substitute some numbers here. If x is equal to 0, solve for y, that would be your y-intercept. That's the easiest one, so we're going to start with that one. X equal to 0, then I would get 2 times 0 minus 1. At the top of the fraction, I get only minus 1. At the bottom fraction, x squared minus 6x would add up to 0 if x equal to 0. And then at the bottom fraction, I get minus 8. So my y-intercept then would be 0, comma, minus 1 over 8. Remember, the y-intercept and x-intercepts are a point. So you're going to show it as a point. To find the x-intercept, you have to let y be equal to 0 and solve for x. So this f of x is y. Y is equal to 2x minus 1 over x squared minus 6x plus 8. So if y is equal to 0, if I cross multiply, this is the proportion. Whatever I have at the bottom of the fraction times 0 would be equal to 0. If I cross multiply this, so it means 0 is equal to 2x minus 1. So I can solve for x. If I go ahead and add 1 to both sides of the equation, divide both sides by 2, so my x would be equal to 1/2. So when y is equal to 0, x equal to 1/2, and this is my x-intercept, 1/2, comma 0. I'm going to show it like an order pair. Now I need to find my asymptotes. To find the horizontal asymptotes and vertical asymptotes, we use what I have at the bottom of the fraction first to find the vertical asymptote. Vertical asymptote, I'm going to abbreviate VA for vertical asymptote. You look at what you have at the bottom of the fraction, let it equal to 0. We already done that here. You said x is equal to 2, x equal to 4. So these are my vertical asymptote. These are the lines that my graph going to get really close to that. To find the horizontal asymptote, we can divide each term here by highest exponents, which is x squared. I can go ahead and multiply each of these terms by x squared and ask myself, as x get really large, what's going to happen to each term? Some of them goes to 0, become almost 0. So once we do that, the next step is to reduce. So it looks like I get x and x cancels. I get 2 over x here minus 1 over x squared over here. I give me 1 minus 6 over x plus 8 over x squared. As x get larger and larger, 2 over x would be almost 0. 1 over x squared would be almost 0. Although what I'm circling would be almost 0. 6 over x would be almost 0. So as 8 over x squared. So this whole thing would be equal to 0 over 1, which is 0. Therefore, my horizontal asymptote would be y is equal to 0. That's my horizontal asymptote. I have my horizontal asymptote. I have my vertical asymptotes. I have my intercepts. How about oblique asymptote? Do we have that? No. Oblique asymptote doesn't exist here. Oblique asymptote would be, do we have an asymptote that is not horizontal, not vertical, but it's like a slanted line? We do have that when we have the exponent at the top of the fraction is greater than exponent at the bottom of the fraction. So if I have x squared over x, then in that case we have oblique asymptote. And we use the long division to verify that. And we did some example of those before. So we have all the information here to graph this. So let's see if we can squeeze the graph down here. This is my y-axis, and this is my x-axis. X is equal to 2. That would be one asymptote. So I'm going to put this line there. If this is x is equal to 2, this should be a dotted line really. And x is equal to 4, so it would be maybe this line here. And y is equal to 0 would be the line that lies right on x-axis. I'm going to do a little modification here to show these are the dotted line. So these are my asymptotes, show it as a dotted line. These are the line that my graph going to get really close to that. So you're going to make these like a dashed line or dotted line to indicate these are the asymptotes, like that. So that would be 2, that would be 4. That's 0. This is y-axis and this is x-axis. So my y-intercept would be minus 1 over 8. So it would be 0.1, would be somewhere close to minus 0.125. So if x equal to 0, y is equal to somewhere right here. Your graph going to get closer and closer to these asymptotes. And then let's pick another one. If y is equal to 0, x is equal to 1/2. We also need some points here to see how this graph behaves. So if I let x equal to, let's say, 5. Okay, if x equal to 5, we can see what y would be equal to. So it would be somewhere around here. So your graph going to get closer and closer to this asymptote this way. And this point would be like that. You can pick a point between 2 and 4, like 3. Substitute the number, then you find the corresponding value somewhere around here. then you can see your graph going to get closer and closer to these asymptotes. And also it's going to get closer to these asymptotes here and get closer to these asymptotes there. That would be the graph. You can use your graphing calculator to show you the graph. If you click on y is equal to function here and input the function 2x minus 1 over x squared minus 6x plus 8 and click on the graph, you can see a similar graph that we did it by hand. And make sure you have your windows set up. I have it for -9 to +9 for x-axis, and for y-axis I have it from -9 to +9 also. You can play around with the scale, but you would see the shape of the graph we did by hand. Here we're going to find the domain and all intercept, all asymptotes, and graph. Well, to find the domain, that's an easy one. We take what you have at the bottom of the fraction. You don't want that to be equal to 0. So if I let that be equal to 0, x would be equal to 2. So for x is equal to 2, this whole thing would become undefined. So I can figure out my domain now. Domain would be the values all the way from -infinity to 2, not including 2. I'm going to use a parentheses, union that with 2 all the way to +infinity. So that's my domain. Now, to find my x and y intercepts, I need to plug some numbers. If I let x be equal to 0 and solve for y, that would be my y-intercept. If I let x be equal to 0, then I get 1 over -2. Now remember, the y-intercept is a point, so I should show it as a point. 0, comma, -1/2. My graph gonna go through point 0 and -1/2. So if this is my x-axis, my y-axis, and let's say this is 1, it's going to pass us through this point right there. Do I have any x-intercept? To find that, I need to let y be equal to 0 and solve for x. If I let y be equal to 0, like I'm letting f of x be equal to 0, f of x is y. If I let that be equal to 0, then that would be equal to x squared plus 1 over x minus 2. If I cross multiply this, would be 0 is equal to x squared plus 1. You notice that I'm not going to get any real solution here. I get x squared is equal to -1. There's no real solution here. So we get those imaginary solutions. What that means is there is no x-intercept because the x would be equal to plus and minus radical -1. That would be plus and minus I. So there is no x-intercept. And then we were going to use the vertical asymptote. Let's abbreviate that, VA. That should be easy one. We look at what they are at the bottom of the fraction, x minus 2 equal to 0, so that means x is equal to 2. So x equal to 2 would be this line here. So I need to make a dotted line here. So this is my vertical asymptote going right through point 2 on the x-axis right there. So this would be x is equal to 2, my vertical asymptote. Well, horizontal asymptote and oblique asymptote, those are the other two I want to look for. Because the exponent at the top of the fraction is higher than the exponent at the bottom of the fraction, that is an indication for having the oblique asymptote. If you recall, we have to do the long division. So let's do that here. If I divide x minus 2 into x squared plus 1, I would get x here. I get x squared minus 2x. You need to find the remainder by subtracting. You change the sign. If you recall, you get 2x plus 1. We should know how to do long division by now. That would be plus 2. So you get 2x minus 4. Again, to find the remainder, you change sign and you get the remainder of 5. So the last term would be 5 over the divisor. As I increase the value of x, this 5 over x minus 2 would be almost 0. So we only left with x plus 2. So your oblique asymptote would be y is equal to x plus 2. There is no horizontal asymptote. If you did divide each term here by x squared, you would see there is no number you can find for that, so it would be none here. All right, I can easily find y is equal to x plus 2. The line If x equal to 0, y is equal to 2, so that would be this point right there. If x is equal to -2, y is equal to 0, so that would be the line. My oblique asymptote would look like that. I'm going to continue. I'm not going to continue. I'm going to ruin my long division here. So I know my graph going to pass us through this point here. I've already defined the y-intercept. So my graph going to get closer and closer to its asymptotes here. So I'm going to draw it like that. And then from this side, going to go get closer to that other line. And if you pick a number like 3, substitute for each x3, you get 9 plus 1 over 3 minus 2. And you get some number up here. And then you can see that from this point, your graph going to get closer and closer to these asymptotes. Then you can always confirm the result of this using your graphing calculator, but that's how you would graph.
If you use your graphing calculator and enter the function here, you can click on y is equal to and enter x squared plus 1 over x minus 2 and hit graph. You can see the graph here. You don't see the oblique asymptote here. However, the shape of the graph appears. Make sure to adjust the window. I have it from -10 to 10 and the scale is 1. You can also go to different website like this one here. It's www.desmos.com/calculator and enter the function and you can see a graph. Also, when you use these tools to show the graph on your calculator, you don't see the asymptotes.